Hey everyone, and welcome. Have you ever wondered about the hidden patterns all around us? The world is just swimming in data, a sea of numbers telling these secret stories. Like, how does one thing actually affect another? Is there a real connection? Well, in this explainer, we're going to pull back that curtain and learn exactly how to find those connections.
Let's put it in real-world terms. Imagine you're running a business. You're pouring thousands, maybe tens of thousands, into advertising. But how do you really know if it's paying off? Is there a direct, measurable link between the cash you're spending and the revenue you're bringing in? This is exactly the kind of mystery we're going to arm ourselves to solve today.
Some connections are just obvious, right? You make more money, you probably spend more money. Easy. But a lot of the time, the link isn't so clear-cut. And that's where statistics comes in. Now, hold on. This isn't about boring math class nightmares. Think of it more like a toolkit for becoming a data detective. It gives us the power to see the real story that's hiding in plain sight. All right, so where do we even start with all this? Well, the most natural, most intuitive first step is to just look at the data. Seriously, before we crunch a single number, let's actually see what the relationship looks like. And this is our first tool, the scatter diagram. It is incredibly simple, but don't let that fool you. It's super powerful. All you do is take your two variables, say ad spend on the bottom and revenue on the side. And for every pair of data you have, you just plot a single point on the graph. You do this for all your data, and suddenly, a picture starts to form. Okay, so what kind of pictures can we see? Well, if you plot all your points and they seem to form a pattern that's climbing upwards from left to right, congrats, you found a positive correlation. This just means that as one thing goes up, the other thing tends to go up too. The example here is perfect. As a family's income rises, their spending usually rises along with it. See, they move together in the same direction. But what if the pattern goes the other way? What if it's sloping downwards? Yep, you guessed it. That's a negative correlation. This time, as one variable increases, the other one tends to decrease. The classic example is supply and demand, right? Usually, when the price of something goes way up, the demand for it goes down. The variables are moving in opposite directions. And then there's the third option. Sometimes you plot all your data and you just get, well, a mess. A random cloud of dots with no rhyme or reason. This tells us there's zero correlation. There's just no clear pattern, no discernible connection between your two variables. They're just doing their own thing. Okay, so seeing a pattern is great, but saying something is kinda sloping upwards isn't exactly scientific, is it? We need to put a number on it. How can we actually measure just how strong that relationship is? And for that, we meet our next tool, the correlation coefficient, which everyone just calls R. Honestly, the best way to think of R is as a simple relationship score. It's one single powerful number that tells us two crucial things: the direction of the relationship, is it positive or negative, and its strength. Now, this score always lives on a scale from -1 to +1. That's it. A +1, that's a perfect positive correlation. It means the dots on your graph form a perfect straight line heading up. A -1, a perfect negative correlation, a perfect straight line heading down. And a 0, right in the middle, that's our random crowd of dots again. Absolutely no relationship to see here. Now, just so you know, there are a couple of ways to calculate this R score. The most common one is the Pearson method. It's the most accurate because it uses the actual values from your data. Then there's the Spearman method. It's a bit different and usually easier to calculate by hand because instead of the raw numbers, it just ranks everything for second, third, and compares the ranks. So really, it's a trade-off. Do you want more precision, or is simplicity more important for what you're doing? So we've got a visual and we've got a score for how strong it is. Awesome. But what if we wanted to describe that connection even more precisely? What if we could draw one single line, the perfect line, that best tells the story of all those data points? And that brings us to our third and maybe our most powerful tool, simple linear regression. This is the method we use to find and draw that one perfect line of best fit right through the middle of our cloud of points on the scatter plot. What we're really doing is creating a mathematical model of that relationship. And that whole model gets captured in this one simple, elegant equation, y equals a plus bx. Let's not get scared by the letters. It's super simple. Y is the thing we're trying to predict, like our company's revenue. X is the thing we already know, like how much we spent on ads. Then you have A, which is just the starting point of the line. And B is the really important part. It's the slope, which tells us how steep the line is and which way it's going. So what's the big payoff here? why go through the trouble of finding this equation? One word, prediction. This is where the magic really happens. Once we have our line, our model, we can use it to make really solid, educated guesses about the future. We can actually forecast what might happen based on the pattern we've already found. And using the line to predict something is surprisingly easy. You don't even need to do the math every time. You just start with what you know, your x value on the bottom axis, then you go straight up until you hit that regression line we drew. From there, you just go straight across to the side axis, and boom, that's your predicted value for y. It's a super simple visual way to make a forecast.
Let's look at a real example from the source data to see it in action. A model was built to predict someone's spending based on their income, and it came up with this equation. So, let's say we know someone has an income of $29,000. We just plug that number into the income spot, and the model predicts their spending or expenditure will be about $7,007. I mean, how powerful is that?
Okay, so this is a really crucial point. We've talked about correlation and we've talked about regression. They're obviously related, but they do different jobs. They answer different questions. Let's just quickly nail down the difference so it's crystal clear.
This table just lays it out perfectly. Correlation asks, hey, how strong is the link between these two things? And its output, its answer, is just a single number, that R score we talked about. Regression, on the other hand, asks a different question. It asks, okay, but what is the specific link? What's the formula? And its output is an entire equation, that line y equals a plus bx. So you see, one measures the strength, the other actually describes the relationship. And honestly, this quote from the source material just sums it all up perfectly. Correlation measures the degree of association, while regression gives the pattern of the relationship between the two variables. It really is that clear. One tells you the strength of the connection, the other tells you the story of that connection. So there you have it. You now have the fundamental tools to look at any two sets of data and start asking some really smart questions. You know how to visualize a connection, how to score its strength, and even how to build a model to make predictions. So the only real question left is, what hidden patterns are you going to uncover in the world around you?